It's time for our special guest. So, if I mention the words Genesis, Salisbury Hill, Sledgehammer, who do you think I'm talking about? Gary Marcus has some remarkable friends, and one of them is someone who, if you're as old as me, was your hero from the word go in rock music, one Peter Gabriel. Will you come and introduce your friend Gary to us?
Thank you.
Oh.
No.
Take my phone.
That's reassuring for an old man who's very humbled to be standing here, and particularly after Alan just spoke from his spot. So I'm just going to throw a few questions out, because here we are at the start of the most fundamental and profound transition we've ever known. Clearly all going to be living in a very different world from anything we've experienced before. And maybe, yeah, we need to spend a little time asking the right questions, or what they might be. Perhaps I'd just throw a punter's thoughts out. What would it require to evolve artificial intelligence into wisdom? Everything is speeding up with AI. Can we match it with our reaction time, or better anticipate what it may bring? And how can we build ethics and compassion and caring into the code? And are there any existing precedents for control systems that we could learn from? Maybe aviation is one. GASP is one of my favorite acronyms. It's the Global Aviation Safety Plan, and it's monitored by the International Civil Aviation Organization. And they actually managed to get agreement from 190 countries, and maybe the same thing could be achieved for AI. All the world's energy and all the world's wealth seems to be heading in one direction. Is it too risky for the world's wealth to fall into such a tiny number of hands? If we do succeed in creating these super intelligent autonomous entities, even if it's 20, 50 years from now, are we going to be their pets and porters as animals have been for us? And what would a hybrid look like? But it's not easy for the bosses behind these AIs. Unimaginable power and wealth, or the fate of humanity. How urgently do we have to come together and create some international regulations to provide the safety structures? And when so many countries are afraid of missing out on the spoils of AI, how can we reliably police any red lines and controls we introduce? The dream worlds of AI possibilities are being blown up like balloons all around us. But maybe, like in the wonderful film Pixar's Up, we are like Carl Fredricksen in his home, and these balloons can carry us up too high and take us to the wrong place. And whenever I get a little too excited about all the amazing good things coming, or terrified by all the bad, there is one man, an AI creator and a fellow AI believer, who sold his own AI company to Uber, who I turned to bring in some reality. He's a bit like a lone sniper, picking away at all the balloons of AI hype and hyperbole, one by one, and adding a little balance in this increasingly crazy, turbulent, and accelerating transition. Gary Marcus.
I'm just going to take a moment to compose myself. Peter wrote that on 2 days' notice or something like that. It was spectacular as everything that he does. I want to thank Wendy and Alan especially for letting me be here today to be part of this amazing thing. It's been spectacular. I'm going to need some water. So I made my title long before I made the talk, and I called it the Grand AGI Delusion. I'm not sure it's quite the right title for the talk, so I made a second title by Ray Kurzweil's daughter, as it happens. Turing Test Today. All right. So I'm going to give my take on the Turing test. It's actually more generous than some others. I'm known for my skepticism, but I'm going to try to find some value in this test that or at least in this paper, I should say. So here's a picture from an original copy of the paper, 75 years old. And I want to distinguish between Turing's question and Turing's test. So we just heard a lot about Turing's test and all the different variations. It's really Turing's set of tests. I'm not a big fan of Turing's set of tests. I think we've already seen some of the reasons. I'll repeat them briefly. But I think his question, can machines think, has gone from being something that a bunch of philosophers might think about to something that is shaping the texture of the entire planet. And really what I want to talk about today is the way that some people's answer, which I think is the wrong answer to this question, is having all kinds of consequences for society. So his implied question, what is thinking, still remains valid and open, even if the particulars of the interrogation test don't really. And as Alan pointed out, we've actually known this at least since 1966. People can easily be fooled. Eliza was a demonstration of that. And fooling an average person doesn't necessarily entail intelligence. That's probably partly, if you want to kind of take an evolutionary psychology perspective, because our brain evolved to detect things like predators and food, not to detect imposters, digital imposters. Most people don't know how to do that. Maybe if they went to graduate school in cognitive psychology, as I did, they might learn something about that, but it's not something ordinary people can be trained on. We can call the over-attribution of intelligence to machines the Eliza effect. It turns out empirically that most of the systems that have so-called beaten the Turing test have actually taught us nothing about AI. You probably haven't even heard of any of them unless you work in the field of AI. There was a system called Perry that pretended to be paranoid, a system called Eugene Gustman that pretended to be a 13-year-old smart aleck boy from Odessa. These have, won in various competitions that people have called Turing tests. They just didn't tell us anything about how to build intelligence. They were gadgets. But now we have something that is also preying on fooling people, which is the large language model, the chatbot. I would say that chatbot mania, which is what we're experiencing right now, represents a profoundly dangerous echo of the Eliza effect. We as a society are placing truly massive bets around the premise that AGI is close, in no small part because LLMs pretty arguably do pass tests like the Turing test. LLMs can fool people into thinking they're people. People will talk to those machines, tell them their most private details and so forth because they have a kind of relationship with those machines. But in reality, large language models are deeply flawed imitators that are preying on the Eliza effect. Now, if policymakers and the public had a better, more nuanced understanding of what thinking is, I think we'd actually be placing different bets. And it's not just money at stake. I mean, I am talking about literally $1 trillion bet at this point. That's the kind of infrastructure money we have put in or are about to put in to large language models. We're letting those who build large language models dictate the very structure of our society. And we're mostly ignoring the costs that large language models have bringing to society. So based on confusion about what LLMs are and are not capable of, governments are increasingly giving AI companies an almost entirely free hand, no regulation at all, with very limited liability for what they are doing. We saw that didn't work out very well, by the way, with social media. They're casting a blind eye to the enormous environmental costs that are just growing faster and faster. We're casting a blind eye to bias, which maybe Abiba will speak to later. We're casting a blind eye to wholesale AI-generated misinformation, LLM-induced delusions, suicides. There's actually an LLM-induced murder. We are creating exemptions from, or considering creating exemptions from copyright law, despite obvious harm to creators. We're enabling companies that may surveil and analyze literally everything you do 24/7 with new hardware that places like OpenAI intend to build. We are amping up geopolitical tensions around, I think, a mistaken notion that whoever gets to whatever it is, GPT-6 first is somehow going to rule the world. And we're handing unprecedented political power to tech CEOs. We're basically moving to a tech oligarchy. It's not just the money. Now, it is clear that LLMs can clearly fool humans. We used to argue, when would AI pass the Turing Test? And you can quibble a little bit, but there are studies now that show that even GPT 4.5, which is no longer the latest model, can pass as a human 73% of the time. Now, there are quibbles. The tests were only done for 5 minutes, and judges weren't trained, and so forth. But the question is, so what? So the machines can beat the Turing test. The problem is we're once again falling into this Eliza trap of over-attributing intelligence to machines. In reality, anybody who studies these systems systematically, especially if they have a background in cognitive science, will realize that they do stupid things all the time. They can't label the parts of an elephant. You might have heard a few years ago there was a problem where they would often draw 6 fingers when you had them draw a hand. This was just a couple of weeks ago. I asked for 3 hands, and I got 5. It's an example of when you go outside the box of what's normally asked of these systems, they have a lot of trouble. Try to get them to draw a time on a clock that isn't 10:10, which is the thing you most often see in the catalogs that are data, and you often get bizarreness like this. You can get some things that might actually kill people if they took them seriously. This is not the proper way to wire a North American plug. I then asked ChatGPT if it could fix it, and all it did was change the color of one of the wires, and we still have a short circuit. This is an example here of what I call river crossing problems. And the systems have been trained on a lot of river crossing problems. And so it's really instructive when you change from the diet that they have been fed on. And now they're even fed on like special examples because the companies have been embarrassed by this. So some of them even have in their so-called system prompts how to handle the river crossing problems. They can still come up with pretty bizarre answers. So well, I'll let you read it for yourself. But the point is that what you get out of these systems is really pastiche, putting together the examples they've seen before. They're a little bit sophisticated than just cut and paste, but at the end of the day, they're cutting and pasting the things that they have seen. To some, these errors might seem surprising, but they don't seem surprising to me because of the work that I did in graduate school in the few years after I went to graduate school. I wrote a paper in 1998 about a problem that we now all call distribution shift, and that I was just illustrating, which is if you take these systems out of the kinds of things they've been trained on, they can often have problems. And it's a complicated technical thing to say exactly what I mean by beyond the space of training examples. But we've seen this over and over and over again. When these systems fail, it's because you push them beyond what they're familiar with. We've seen it in driverless cars. My favorite example was someone used the summon feature with a Tesla, where you press a button on your phone and it's supposed to drive across a parking lot to visit you. Somebody did this at an airplane trade show at an airport, and it ran, the car ran directly into a $3.5 million jet because there was nothing in its training set. So that was what we call distribution shift, about what to do in the case of an airplane. And it didn't actually learn to reason like a human being. And that's what we see with LLMs. They're not actually learning to reason. They're just really leaning hard on the examples they've seen before. So I wrote about this in 1998. I wrote about it again in 2001, where I predicted we would see hallucination errors. None of this really seems new to me. And what I've heard for a quarter century is we're working on it. We're going to solve it next year with a little bit more data. I've heard this over and over again. I think by now, maybe we can see that that's not really the case. In fact, I got a certain measure of vindication. People in the front row can see it best, with a paper that Apple released earlier this year. And the venture capitalist Josh Wolf said, Apple just Gary Marcus'd LLM reasoning ability. As it showed, once again, the same problem of distribution shift. So it showed these systems could learn the Tower of Hanoi puzzle with 7 rings on 3 pegs, but it couldn't do it with 8. It didn't learn the general procedure. It had just basically memorized things at some level. Now, the alternative view is the idea of scaling is all you need. What has driven the last few years, last 5 years in AI, was basically a paper in 2020 or 2021 by OpenAI that showed, I wish I had it on a graph here, showed a graph of systems getting better as a function of more data. And what I said is, you can't expect that to go forever. But the propaganda has been that you could expect it to go forever. And the leading acolyte of propaganda is this man, Sam Altman, who's the CEO of OpenAI. So I'm going to play you just a little clip where he talks about scaling, and he tries to imply that it is a law of the universe. Scaling meaning we add more data, we get more performance. And the notion is if you give us an indefinite amount of money, he literally once talked about $7 trillion, that somehow this is going to get us to artificial general intelligence. Listen how slick he is as he talks about this idea.
This whole effort, which was hugely expensive in terms of people and time and dollars and everything else, was an experiment to further validate that the scaling laws keep going.
Yeah.
And why? And it turns out they do, and they probably keep going for a long time. I accept scaling laws like I accept quantum mechanics or something, but they still don't, like, I still don't know why. Like, why should that be a property of the universe? So why are scaling laws a property of the universe?
So, I mean, it's an incredibly slick piece of rhetoric. And he didn't just, convince the two people in that room. Essentially, all the federal governments in the world are now basically believing that story. Consistent with this idea was something from Richard Sutton, which almost everybody in the field probably knows, probably everybody, which Sutton called The Bitter Lesson. It's a brilliant paper. It's a page and a half. And it's cited constantly. And it's sort of partly right, as I'll describe in a minute. So the idea of scaling, the idea of his paper was basically that big data and compute always win. So there's been a long history in AI of trying to do things the hard way, trying to figure out what is the knowledge that I need to solve this problem, which is very difficult engineering. And the beauty of large language models is you don't have to do any of that. And what he was arguing, not specifically to large language models, this was before they were popular, is that every time that he could notice, simply putting more brute force, more data, was the best way to solve a problem. So, of course, the scalers loved that. But it never made any sense to me. Moore's law, for example, ran out. Moore's law was a law for a while, but it was really just an empirical generalization. It wasn't a law like gravity. It wasn't a law of the universe. And so I argued in 2022, in a paper that basically got me excommunicated from the AI field, that, I'm not even kidding, that scaling was not a law of the universe and that it was not going to solve the core problems that I had been nattering on about for 25 years. It wasn't going to solve hallucinations. It wasn't going to solve these stupid reasoning errors. And they were so mad at me. All of them. Sam Altman went after me, called me a mediocre deep learning skeptic. Elon Musk posted a very funny cartoon making fun of me. I mean, it is a funny cartoon, I'll give him that. And Jan LeCun said not only is AI not hitting a wall, but cars with the AI aren't hitting walls either, and so forth. So they were really upset with me. But over the last year, scaling has actually clearly lost momentum. One of the first people who was intellectually honest about this was Satya Nadella, who actually invested a lot of money on scaling. And I was shocked last November when he kind of acknowledged it wasn't really working out as well as he thought. In fact, he basically paraphrased what I had said. He said, in the last multiple weeks, there's a lot of debate about have we hit a wall with scaling laws? Is it going to continue? And again, the thing to remember is these are not physical laws. They're just empirical observations that hold true like Moore's law. So he sounded exactly like me. I was astonished. And the reason that he was saying this is he could see the writing on the wall that they were no longer getting the rewards. So in the period from 2020 to 2023 or so, people kept putting in more data, and they were getting these really large improvements in accuracy with these systems. But what he could see from internal data, clearly, was that wasn't really true anymore. And then in April 2025, not so many people took note of it, but there was a very large language model made by Meta called Llama 4, and it just wasn't that good. And so if you would imagine these curves that people were plotting, it kind of fell off the curve. Well, maybe that was just Meta. What really, I think, has changed the whole world, certainly changed my reputation, was just a month ago, a little over a month ago, on August 7th, GPT-5 came out. And Altman, being the master salesman that he is, had hyped GPT-5 as if it was going to be artificial general intelligence. And you had a whole world of people who had built things, like companies who had built prototypes with GPT-4, and they didn't really work. They didn't work that well. They would sort of work, you got a proof of concept, you could see the future. But they didn't work reliably enough to put in your business. And everybody was banking on GPT-5 was going to be the solution. And Altman spent 3 years campaigning for this, writing things like, AGI has been achieved internally. He wrote in a Reddit post that everybody sort of took down his notes and tried to decipher what he was saying. So when it came out, GPT-5, and it was just okay, but it wasn't really fitting what the scaling laws would have said, a lot of people, I think, woke up. In hindsight, the bitter lesson about the bitter lesson is that scaling works only well for some problems, mostly pattern recognition problems, and Alan made a similar point, but not others. It's not a universal solution to all of the things in intelligence and cognition. Scaling has made generative AI much better at the kinds of things that it is good at, like brainstorming. But it hasn't helped that much with its core weaknesses around reliability, hallucinations, poor reasoning, poor planning, and so on, in the face of novelty. So scaling has helped with things like object recognition, autocomplete, voice recognition, brainstorming, all of those things, but it hasn't really helped with problems that can't be beaten by brute force, and it hasn't really helped with this problem of distribution shift that I keep harping on. And just in the last week, we've seen more evidence of this. So Eric Topol, who's been very pro-AI, he's a, I believe, cardiologist who writes about AI in medicine quite a lot, reported that there were 2 new studies that showed that what we were finding in the labs wasn't holding up outside the labs in the real world. This is another example of distribution shift. It goes to the issue of benchmarks. Maybe we'll have more time to talk about it. Turing's test was the first benchmark. How do you measure what a machine is doing? And what we find often is that people play to those benchmarks. There's something, in fact, called Goodhart's law, which is basically about teaching to the test. And when things become public, people teach to the test, and then the results don't mean as much as they used to. So what's happening in medicine is the same thing. People are teaching to the test, but you take things outside the test into the real world, they don't work as well. And then the next thing that I'm going to show you just blew my mind, almost as much as Peter's introduction, which was Richard Sutton kind of waved the flag in an incredibly gracious way. And he said, you were never alone, Gary, though you were the first to bite the bullet, to fight the good fight and make the argument well, again and again for the limitations of LLM. I salute you for this good service. This is the man who invented the bitter lesson, and he came to see that LLMs were not it. And he and I agree in part about what we might do next and disagree. We still have different perspectives, but he really came to say scaling is not enough, and to say it incredibly graciously. So to bring this back to Turing, imitation is not actually the essence of intelligence. It's maybe a part of intelligence, but it's not the whole thing. Explorations of LLMs have shown empirically that you can have a system that is spectacular at imitating human intelligence. ChatGPT is great at that, or at least at many aspects of it. But still, in other circumstances, it can be utterly discomprehending. I meant to say on an earlier slide, I call these errors discomprehension, when it just doesn't seem to understand what's going on. We still need to figure out how to build machines that can think reliably. And this ties with what Alan was saying about safety. If you can't have fundamental reliability, how are you going to get safety out of these machines? The payoff in building AI that we really could trust would be immense. As Peter said, I actually really love AI. I know my reputation on the street is Gary is an AI hater, but I want it to work. I want it to help us with science and medicine. In a minute, I'll give you an example of my favorite piece of AI that does help, I think, with science and medicine. It's just that scaling LLMs turns out to be the wrong answer, and we spent half a decade trying to make that work and not really trying to consider other hypotheses. Now, the economic implications in an overinvesting in scaling might be enormous. I mean, we're talking about, as I said, $1 trillion bet. It's not clear that the bet makes sense. And then there's the environmental implications. Altman's talking about wanting 250 gigawatts of power. And we are also, sacrificing all the art and writing and so forth of creators. We're sacrificing so much on this bet about scaling. We wouldn't be doing this if we didn't believe in scaling, and we shouldn't. And the payoff so far has been pretty minimal. The other thing that's really changed the tide in the last month is a study from MIT, which showed that 95% of businesses aren't getting ROI on their return on investment for their experiments with generative AI. Everybody finds it interesting. Very few people are actually making money by doing it. Another study, a report from the Financial Times, I'm quoting here the first paragraph because I love it so much. It said, the biggest US listed companies keep talking about artificial intelligence, But other than the fear of missing out, few appear to be able to describe how the technology is actually changing their business for their better. To me, like, it's this incredible emperor's no clothes situation where everybody's saying, I'm going to do this thing, but nobody can explain exactly why they're doing it. There's a new word that just came out last week, which is work slop. Part of the problem is you can use this form of AI to make it appear that you are doing the work that needs to be done. But quoting from that paper, AI-generated work content that masquerades as good work, but lacks the substance to meaningfully advance a given task. That's what they call work slop, and that's not really helping anybody with productivity. Meanwhile, the economics are just insane. So one recent study from the Bain and co. found that the expenditures are expected to be $2 trillion, and which makes them $800 billion more than revenue. This is by 2030. So like, this is a huge bet that is not actually working. Makes me think of a classic book, which you should all read if you haven't, The Extraordinary Popular Delusions and the Madness of Crowds from 1841. And of course, that book is mostly about things like tulip mania. I think it might be time for a revised edition about LLM mania. Okay, what would be better? And here I will overlap a little bit with Alan's talk in a moment. The first thing I would say is we have to stop looking for silver bullets. Everybody keeps looking for the one algorithm that would rule them all. And we're not going to find it. You know why we're not going to find it? Because thinking isn't one thing. There's a wonderful quote from about 10 years ago from two cognitive psychologists that I like, which is, there's no one way the mind works because the mind is not one thing. Instead, the mind has parts, and the different parts of the mind operate in different ways. The whole LLM hypothesis is that the mind works in one way, which is by using this thing called attention and looking over large amounts of data and doing sequence prediction. This is just one of the things the mind does. Mind doesn't do it exactly that way, but yes, we do a bunch of prediction. That's part of what we do. But as we do different tasks, we use different mechanisms. In fact, I'll go further and say that the very idea of AGI, of artificial general intelligence, might not even be the right goal, at least right now. The Turing paradigm was a single general-purpose Q&A system, the one that he contemplated 75 years ago, long before we had any idea how to build it. And in some way, he was quite prescient that somebody might try. But LLMs actually try to fit that bill, but what they wind up being is jacks of all trade and masters of none. It's phenomenal to someone who worked in the AI before LLMs that you can have a single system, you can ask any question, but they don't work that well either, and so it's a little bit of a trade-off. The human mind, in contrast, is made up of many different modules that are dedicated to different kinds of tasks. And there's a famous book by the philosopher Jerry Fodor that I think bears rereading called The Modularity of Mind. Some of the best results in AI have in fact come from highly specialized, highly modular systems that themselves have subcomponents that do very specific things and that really only try to do one thing. My favorite example of any AI that's ever been built to date is probably AlphaFold 3 from DeepMind, which is of course based here in London. And what it does is a single thing. It does not try to answer, it does not try to write sonnets or, evaluate sonnets, right? All it does is take a sequence of DNA nucleotides and predict where a bunch of atoms will be. It's about as specialized as you can get. And it's fantastic. Every biologist in the world knows about it, and many of them use it, every day. Maybe we don't need AGI right now. Okay, second clue, and this is where our talks maybe most overlap. Alan already talked about Kahneman System 1 and System 2. And the notion is that we have this fast automatic system, and we have this more slow and deliberative system. LLMs are really like System 1. Generative AI is another word for LLMs, are really like System 1. They're fast, they're automatic, but they're not deep. They're not really reasoning, even though there's some PR around that right now. And you can't really trust them to do abstract reasoning. So LLMs or generative AI are kind of like Kahneman System 1. And classical symbolic AI, like Marvin Minsky, who Alan mentioned, is really mostly more like System 2. And there's been this horrible relationship, emotional relationship between the people who have done the stuff on the left and the stuff on the right. They really don't get along. Part of why I am hated in the field is because I'm a little bit closer to the System 2 side, and the System 1 people are empowered and feel like they weren't for a while, and they're bitter. There's all kinds of weird dynamics around this. But the fact is neither approach on its own has worked. And so what I have been pushing actually since 2001 is trying to find some integration between the two. The subtitle of the 2001 book was Integrating Connectionism, that's another word for neural networks, and cognitive science. So the system one-ish stuff is good at learning and poor at reasoning. It's very data hungry. I mean, this is why these companies are fighting for every last morsel of data they can get and willing to break laws like copyright laws that get it. They're uninterpretable. We don't really know what these systems are doing. And they're prone to hallucinations. We all know this. On the other hand, on the positive side, they're scalable. You make them bigger and they do get better. The classical symbolic AI stuff was good at reasoning, not really very good at learning. People have typically handcrafted them, although that's not necessarily a logical requirement, and there's some people who have tried to push beyond that. They're data efficient. They're interpretable. You can figure out what it is they're doing. They're not perfectly interpretable, but they're much more interpretable. They don't tend to make these weird hallucination errors. And it's unfortunate that they're handcrafted because that takes a lot of work. And they're grounded in facts. You can put in a database and they will stick to the facts in the database, which really should be like an absolute minimal requirement. Like nobody would use a calculator that makes things up, but people use LLMs that makes stuff up. So we need to bring them together. That's my second lesson for you. The human mind combines both, and if we can figure out better ways to do that in AI, we might be able to create an AI that is interpretable, verifiable, which very much goes to Alan's point about safety. If you can't verify, how is it going to be safe, and responsive to data. Third clue from the human mind is that we should embrace the thoughtful use of innate structure. So there's this another weird piece of sociology, which is the field of AI right now is dominated by people who do machine learning. Machine learning should be a good thing, right? It just means put in data into your system, it will learn something. That's a good thing. But the problem is, it's kind of a version of, you give a man a hammer and he thinks everything is a nail. They're trying to make everything a learning problem. And there's some things you probably don't need to learn and shouldn't. You know, what biology gives us in the form of the genome is instructions on how to build brains, basically. That's what the genome says, how to build a brain and how to build a body. And then the brain does the learning. But it's not nature versus nurture. It's really nature and nurture. And the current systems kind of ignore the nature stuff and do everything with learning. This is absurd. I always like to quote Elizabeth Spelke from, I guess, 30 years ago, beautifully was talking about children. And she said, look, if the children are born, and she had empirical evidence from studies of babies that she pioneered, if children are born knowing what objects are, knowing what sets are, knowing what places are, what events are, having some abstract categories to guide the world, then they can learn about those things. But if you just leave them as a blank slate, just trying to learn from correlation, essentially, they don't really learn that much. They probably wouldn't learn that much. So again, if you look at the successful examples, there's lots of innate structure. LLMs don't have a lot of innate structure, but if you look at AlphaFold, it doesn't learn it all from the data. Rather, it has built-in things that tell it how to think about, essentially, or how to analyze the structure of things in terms of the molecular space, in terms of the sequence of nucleotides and so forth. And then it starts to learn. So this is actually the most specialized learning system I know. It is there to learn one thing. It gets a whole database called the Protein Data Bank that gives it a kind of correlations between a bunch of proteins that we know how to work, tries to derive something from that it can extend somewhere else. But it's much, much more focused than just like stimulus and response and hoping for the best. It's a very carefully crafted piece of equipment. The fourth, which I won't go into detail because I think we're probably running out of time, but is we need world models in our system. So a world model is what Alan was talking about. It's something in your head that tries to make sense of the stuff that's out there. It may not be perfect. As Alan points out, we may even deliberately fool ourselves. You know, we might enjoy the play, and we know that that it is a model of a fictional world rather than an actual world. But we make world models all the time. Every time we see a movie, every time we read a book, every time we meet a new friend, we have these models in our heads. Large language models don't do that. They just pastiche together the text. They can fake it a little bit, but a really good example is they can't even play chess. So large language models, unless you do a very special purpose one, will get trained on millions of games of chess because they're part of the data that in the scrape of the internet that they're trained on. They get trained on the explicit rules of chess. They can spit back those rules. You can say, can a queen jump over a knight? And they'll say no. And then in the middle of the game, they'll have a queen jump over a knight. They haven't managed to internalize all that stuff into an actual model of how chess works. So you can read that essay of mine in the Substack about the crippling and widespread failure of these systems. So I'm very nearly done. We need to figure out how we can get AI systems to derive models from the world. We know how to build them in. We know how to build a chess computer. But we don't know how to build a system that can learn something like chess and follow those rules. Our safety depends very much on us being able to do that. So just a couple more slides, a plea for intellectual humility. Tech CEOs are absolutely convinced that they're gods and that they get to make really important decisions for us. Here's Sam Altman just a week ago saying, over the next year or two, scarcity of GPUs could force painful trade-offs, cure cancer versus global education. So give me all the money in the world to make GPUs is basically what he's saying. Now, this is, to use the word that Alan used earlier, bullshit. We are nowhere near being able to cure cancer in the next 2 years. This is just not going to happen. Even if we had perfect intelligence, we'd still have to do the lab work. It's just not a thing. And then it turns out, of course, that what he really cares about is money. So he's figured out a way to make money. What he's going to do with all those chips is to make AI slop. He's going to make a new TikTok competitor using all these AI chips to make fake video. Like, who appointed this man to be our god? And I don't mean to pick entirely on Sam, because you also have people like Dario Amodei, who recently said, he says there's a 25% chance of things going really, really badly, by which he means the extinction of the entire species. I have a lower probability, but it doesn't matter. And he's betting on the 75% chance it won't go that way. He's betting the species for a 3 out of 4 chance that he will become obscenely wealthy. And you don't get a vote. That's what I mean by they convince their gods. So this is my last slide. Turing was much more modest. He was like, here's some ideas, let's think about them. He didn't say he was right, and nowhere did he say you should, use version 7 of my test. It wasn't structured that way. What he said was this. This is the last lines in the paper that we were celebrating today, and the last lines in my talk, essentially. Again, I don't know what the right answer is, but I think both approaches should be tried. We need to try many approaches if we're going to get to AI that works, not just one. And he said, we can only see a short distance ahead. That's still true 75 years later. But we can see that there's plenty that needs to be done. I love that intellectual humility. I think we should apply it now as much as we did then. Thank you very much.